It's almost second nature, isn't it? Reaching for that glass of water during a meal. Well, we all do it kind of instinctively without really a second thought. But how often do we actually stop and consider the science behind it? Is drinking water with your meals actually good for us? Or, could this really common habit be influencing our bodies in ways we don't even realize? So our deep dive today is going to unpack this surprisingly intricate relationship between mealtime hydration, our digestion, and even, believe it or not, our body weight. It's a topic that's way more complex than just, a simple glass of water might suggest.
And what's truly striking, I think, is that despite how universal this is, how common it is, the research isn't nearly as clear-cut as you might expect. Our sources for this deep dive were looking at a detailed editorial and also a large-scale research study. They really highlight just how nuanced and, honestly, sometimes contradictory the information out there can be.
Absolutely. So our mission for you today is really to try and cut through some of that noise. We want to give you the clearest possible picture based on these sources we've looked at, help you understand what's really going on inside your body when you take that sip with your food. Okay, so to start, let's maybe lay down the absolute fundamentals. Beyond just quenching our thirst, what exactly is water doing in our bodies, especially when we talk about digestion? How does it fit into that whole sort of orchestrated process?
Right. Well, water is, it's truly indispensable for life and for pretty much every single bodily process. Think of it less as just a beverage and more as a core structural component of your cells. It's a crucial solvent, dissolving countless compounds for all those biochemical reactions happening constantly. It acts as the main medium for cellular transport, carrying nutrients where they need to go, flushing waste products out. Water also contributes massively to thermoregulation, helping maintain your body temperature. It lubricates joints, acts as a shock absorber, and critically for digestion, water facilitates what we call hydrolysis reactions. These are essential processes where water molecules actually break chemical bonds. That's fundamental for dismantling the complex proteins, carbs, and fats we eat into smaller bits your body can absorb.
Wow, okay. That's a lot more than just being thirsty. And our bodies are these incredibly sophisticated machines, aren't they? Constantly managing what we eat and drink. We know digestion itself happens in several phases. Could you maybe walk us through those main stages?
Certainly. Yeah, digestion typically involves three main phases. First, there's the cephalic phase. This actually starts even before food enters your mouth. Just thinking about seeing or smelling food can trigger it. Your brain sends signals preparing your digestive system, like starting saliva flow with enzymes, salivary amylase, which begins breaking down carbs. Then comes the gastric phase. That's when food enters the stomach. Here, the stomach stretches to accommodate the food, acid secretion ramps up, and initial protein breakdown starts. And finally, there's the postprandial phase. This just refers to the period after the meal as food moves out of the stomach and into the intestines for more digestion and absorption. What's really fascinating here, I think, is how the body's internal sensors are involved throughout all this. We have things called mechanoreceptors, chemoreceptors, and thermoreceptors, basically tiny sensors for pressure, chemicals, and temperature, all located in the upper GI tract. When you eat, these get activated by the food stretching the stomach and the chemical presence of nutrients. For instance, that stomach stretching activates mechanoreceptors, sending signals up to the brain. This process also influences these nerve responses, vasovagal reflexes, that help relax the upper part of the stomach. And that contributes directly to those feelings of satiety and fullness, the signals telling us we're getting full.
So our bodies are constantly reacting, sensing everything we put in them. Pretty amazing. But is this complex understanding, is it all relatively new science? Or have people been thinking about this whole water with meals thing for a long time?
Oh, it's quite illuminating to look back, actually. This isn't just some modern scientific puzzle. Traditional Persian medicine, for example, through really esteemed figures like Avicenna and Razi, had very specific views on mealtime hydration. They actually cautioned against excessive water consumption right at mealtimes. Their belief was it could weaken the gastrointestinal tract and potentially, down the line, increase the risk of organ diseases.
Right, so not necessarily don't drink water, but be careful about how much and when.
Exactly. For most people, their guidelines discourage drinking water or even eating water-rich foods shortly before or right at mealtimes. The exception they noted was for individuals with particularly high metabolic rates and genuine thirst sensitivity, what they often called having a warm constitution. Avicenna, specifically, advised against drinking water during or immediately after intense physical activity and even suggested waiting a bit after waking up before drinking water. The core idea was that optimal hydration should really match up with genuine thirst. They also had thoughts on temperature preferring cool water, but not excessively chilled, and specifically avoiding lukewarm or warm water, which they thought could harm the GI tract. And water, they said, should be sipped slowly to kind of prepare the system. For better overall health, they recommended extending the gap between finishing a meal and then drinking water. And interestingly, these traditional views also suggested avoiding drinks during and right after meals, maybe waiting an hour, hour and a half, specifically to manage things like flatulence and bloating.
Okay, here's where it gets really interesting for me. How do these ancient cautions, which sound quite specific, sometimes even strict, how do they stack up against what modern research tells us today? So we've looked back at that ancient wisdom. Let's fast forward now. What are contemporary studies actually revealing about how drinking water alongside our food impact those really crucial feelings of fullness and hunger?
Well, it's interesting because one study actually uncovered a rather surprising finding. It suggested that alternating between food and water intake during a meal might counterintuitively increase overall energy consumption. The theory behind this is that it reduces something called sensory-specific satiety, or SSS.
Sensory-specific satiety. What exactly is that? Can you break that down?
Good question. Yeah, SSS is basically the decline in how pleasant a food's taste, smell, or texture becomes after you've been consuming it for a bit. You know how the first few bites of your favorite meal are amazing, but after a while, even if you're not physically full, that specific flavor just isn't quite as appealing anymore. That's SSS. So by switching between food and water, this study proposed, you might kind of mitigate that decline. You might prolong the meal, keep things interesting longer, and as a result, actually eat more food. It also found that drinking water with meals was positively linked to food intake, maybe because it helps with oral thirst, just making it easier to keep eating. But it's important to note, while water seemed to influence those feelings of fullness and hunger during the meal, these effects didn't necessarily stick around after the meal, which suggests they might change independently of the actual calories you took in.
That's really counterintuitive, isn't it? The idea that alternating might lead to eating more.
Mhm.
Okay, what about another factor then, the temperature of what we drink? Does that play a role in digestion?
Oh, absolutely. The temperature of your meal, and that includes any liquids you have with it, plays a quite significant role in gastric emptying. That's, how quickly food leaves your stomach. One study showed that a hot meal around 60 degrees Celsius actually led to faster gastric emptying compared to warm meals, like body temperature 37 degrees or cold meals at 4 degrees. This was seen for both liquids and solids, especially in the early phase, because the food temperature quite quickly equilibrates with your body temperature once it's inside you.
So hotter gets things moving out faster, at least initially?
In that early phase, yes, it seems so. But then, conversely, some scientists suggest that meals right at body temperature, 37 degrees Celsius, regardless of whether they're liquid or solid, might actually induce a more profound relaxation of the stomach muscles, which could potentially delay the initial emptying. And on the colder side, well, cold temperatures can cause smooth muscle contraction and activate these specific TRP channels that are like temperature sensors in our gut. This has led to some speculation that reducing the temperature might actually slow down gastric emptying. It's also worth pointing out that hot liquid meals, specifically, seem to speed up emptying within the first 30 minutes more noticeably than hot solid meals did.
Okay, that's a crucial difference then, liquids versus solids. How exactly do they move differently through the stomach? Is it a different process?
Yes, indeed. The emptying process for liquids and solids is governed by pretty distinct mechanisms. Liquid emptying is mainly influenced by the proximal stomach, that's the upper part, near the esophagus. Solid meal emptying, on the other hand, is more controlled by the lower part, the gastric antrum, and the pylorus, which is the valve connecting to the small intestine. However, and this is really important, when you match the calorie content and the total volume, the emptying times might actually end up being quite similar, regardless of whether it started as liquid or solid or other compositional differences. This really underscores that the caloric load, the energy content of the meal, is often a more critical factor than just the volume in regulating how quickly the stomach empties.
Right, okay. Now let's turn to something that might completely flip your expectations. This could challenge a lot of the conventional wisdom floating around about water and weight management. We're going to look at the findings of a large-scale cross-sectional study. This was done among Iranian adults, and it explored the association between how much water people drank and general obesity. And honestly, this one's a bit of a head-scratcher.
It really is. This study uncovered some genuinely surprising results. It found that individuals who reported consuming more than 8 glasses of water per day actually had 78% greater odds of having general obesity compared to those who drank less than 2 glasses a day. And this association remained even after the researchers adjusted for other potential confounding factors like diet and activity levels. Furthermore, people consuming 1 to 2 glasses of fluids between their meals had 34% greater odds of general obesity compared to those drinking less than 1 glass between meals. Though, interestingly, the study did note that abdominal obesity, specifically measured by waist circumference, didn't show a significant link with higher water intake after all those adjustments were made.
Wow. Okay, this really flies in the face of what so many of us hear all the time, doesn't it? We're constantly told, drink more water to lose weight. Yet this big study suggests, well, the opposite association. How on earth do we make sense of this apparent contradiction?
That's precisely why understanding the type of study is so critical here. The key thing to remember isn't necessarily that water causes obesity, but that this was a cross-sectional study. That means it's just looking at data from a single point in time. It can show an association, but it cannot tell us about cause and effect. It can't infer causality. So, a very plausible explanation is something called reverse causality. In other words, it's quite possible that individuals who are already obese might actually be drinking more water, perhaps in an attempt to manage their weight or lose weight, rather than the water itself causing the obesity.
Ah, I see. So the behavior follows the condition, not the other way around. They're drinking more because they're trying to deal with existing weight issues.
Precisely. That's a strong possibility. Another really key limitation is that the study didn't ask about the specific type of fluids consumed between or during meals. While plain water is very common in Iran, other drinks like dew, which is a yogurt drink, or even sodas, are sometimes consumed with meals, and of course sugary drinks are well known to be linked to weight gain. So it's possible that not all of that reported fluid intake was just plain water. And we absolutely have to acknowledge that this specific finding does contradict quite a bit of other research. There are studies suggesting higher water intake is linked with lower energy intake, or that it can help prevent obesity, or that drinking water before meals can aid weight loss, at least in certain groups. It really just highlights the complexity and the ongoing debate in this area of science.
Yeah, this whole journey, looking from ancient wisdom right through to these modern, sometimes conflicting findings, really highlights one thing clearly. There just aren't simple, universal answers when it comes to mealtime hydration. Both the historical insights and the current science present these really nuanced and, yeah, sometimes contradictory viewpoints.
Absolutely. I think this deep dive really underscores the need for more research, specifically more robust studies to try and delineate clearer, evidence-based guidelines. Our current understanding is definitely still evolving, and there are significant gaps in the research that make it pretty difficult to give out definitive one-size-fits-all recommendations right now.
That's such a crucial takeaway. So what does this all mean for you, listening right now? What really stands out to you from these different pieces of information? It just goes to show, doesn't it, how even something is seemingly basic, as automatic as drinking water with a meal, has all these layers of complexity that science is still trying to fully unravel. It really reveals just how intricate our bodies are. So we've gone from that ancient advice, sort of cautioning against too much water with meals, all the way to modern studies showing how liquid temperature affects digestion speed, and even that really surprising link found between higher water intake and obesity in one large population study. A link that, as we discussed, might well be a case of reverse causality, not cause and effect. So maybe next time you reach for that glass of water with your meal, just take a moment. Consider not just what you're drinking, but maybe also when and at what temperature. And perhaps reflect on how much of it feels like it's truly serving your own unique digestive well-being. It turns out, even something as simple as that glass of water has layers and layers of complexity still waiting to be fully understood. It makes our everyday habits a pretty fascinating frontier for science, doesn't it?